Good afternoon, students. Today we'll study the rest part of our chapter heat transfer or flow of heat. Let's now study about the equipments which are being used in the transfer of heat. So most of the chemical and pharmaceutical industries employ a variety of heat transfer equipments. Okay. So the materials which is to be heated may be liquid or gases and occasionally solids also. But when there is a solid, it is a separate case. Okay. And the heating media may be a hot fluid or a condensed steam. The heating source which we are using, it may be a fluid or a steam. So some of the process which involve the heat transfer in pharmacy is like a preparation of starch paste for the granulation, crystallization, evaporation, distillation. These all are the various processes, okay, which involve the heat transfer mechanism. So the devices which are used to transfer heat energy from one fluid to another fluid through any metal wall, okay. So these are termed as exchangers or interchangers, okay. So in any industry, the heat energy is transferred by various method. Principal, construction and working of those equipments are used for the transfer of heat energy. So first equipment is heat exchanger and second will be heat interchangers. So today we will study heat exchanger. What is meant by heat exchanger? Okay. These are the devices which are used to transfer heat from one fluid to another fluid. Like one fluid means hot gas or steam to another fluid, that is liquid, through a metal wall. These are known as heat exchangers. It can be classified on the basis of what is the type of fluid flow arrangement, means the fluid which is flowing through the heat exchanger is of what type. It may be parallel flow heat exchanger, it may be counter flow, or it may be cross flow. Okay. The liquid and the heating medium is flowing in same direction, then it is parallel flow. If it is in opposite direction, then it is counter flow, and if it is crossing each other's path, then it is cross flow heat exchangers. So let us understand first parallel flow heat exchangers. What is parallel flow heat exchanger? It is also referred as concurrent stream exchanger. Okay. The hot and the cold fluid streams enter together at one end and flow parallelly with each other in the same direction, and also leave together the exchanger at another end. Okay. With that parallel flow, the temperature difference between the two fluid is large at the entrance end and it becomes small at the exit end. It is an obvious process. Then overall measure of the heat transfer driving force will be the log mean temperature difference is less than for counter flow. Okay, so the heat exchanger surface area requirement will be larger for counter flow heat exchanger with same inlet and outlet temperature for hot and cold fluid. According to this, when the fluid and the heating medium is entering the exchanger, it will face a large temperature difference, but at the time of the exit of those two, like the heating medium and the liquid which is to be heated, the temperature difference will be small. Okay. Now next one is counter flow heat exchanger. Counter flow, also known as counter current exchanger. In this type, what happens? The hot and the cold fluid flow parallel but in opposite direction. Okay. If one is entering, then one liquid is entering from the other side and another is entering from the opposite side. The hot fluid entering at one end of the heat exchanger and the cold fluid is entering at other end of the flow path. Now what is the advantage of this counter flow heat exchanger? First one is thermodynamically superior to any other flow arrangement. Okay. And second one is it produces highest temperature change in each fluid, because both of the fluids are entering to the exchanger from the opposite sides. Third one is the cross flow type heat exchanger. Okay, in cross flow type, what happens? One fluid flows perpendicular to the second fluid. That is, one fluid flow through the tube and the second fluid passes around the tube at right angle, like this. This is the diagram of cross flow heat exchanger. Okay, you can see that one fluid is flowing towards the right direction and the opposite fluid enters just perpendicularly above that the flowing fluid. Okay, so this is a cross flow heat exchanger. So some examples of heat exchangers are, first one is your tubular heater, also known as shell and tube heater. Second is multi-pass heater, or third one is the two-pass floating head heater. So let us see the first one, that is single pass tubular heater. Okay, or also known as tubular heater. So what happens in this shell and tube heater? It is the simplest form of a tubular heater because it is a single pass tubular heater. Okay. Now let us see the construction part of this. Construction, it consists of a bundle of parallel tubes. You can see that parallel lines are there. So those are parallel tubes which are relatively thin walled. Next one is, the end of these tubes are expanded into two tubes, that is B1 and B2. End of the tubes is expanded. Okay, you can see that B1 and B2 is written over there. Now the bundle of tubes is enclosed in a cylindrical shell or a casing, that is C. Okay, these tubes are enclosed in a cylindrical shell or casing, that is your capital C, to which the tube sheets are fitted. All these tubes are been fitted inside this casing. And many heaters have a cast iron shell. It depends, okay, what type of heater you are using. Now there are two distribution chambers, that is D1 and D2, which are provided at each end of the casing C. Two distribution chamber you can see. One is at the below, that is D1, and other is at the above, that is D2. Again, the fluid inlet is provided to the distribution chamber D2. Then the heated fluid outlet is provided to the distribution chamber D1. The fluid which is to be heated is entering from the distribution chamber, that is D2, and the outlet is provided at D1. Two covers are there, that is E1 and E2. Okay, to close the distribution chamber from the sides. These are side cover. E1 and E2 are the side covers. Now steam or other vapor is introduced by a connection F. Again, the heating medium, that is steam or the vapor, is entering to the casing from the connection, that is F. So there are some provisions are made for the escape of non-condensable vapor. Okay, the vapor which is non-condensable will be removed from this K point and condensed vapor to drain at G point. Okay, condensate outlet is G and the vapor which is non-condensable will be removed from the point K. Now how this tubular heater works? In case of working of this, normally steam or any vapor is introduced through a steam inlet, that is F, into the space which is surrounded by the tubes. Okay, the steam flows down the tubes, steam is getting flowed through the tubes, and in this process when the heat is getting supplied by the means of steam, the tubes get heated rapidly because due to the high values of steam film coefficients, and the condensed vapor drains through the condensate outlet, that is at G point, and non-condensable gases, if there is any non-condensable gases, then it will escape through the vent K, which is provided at the top of the casing. Now next, the fluid which is to be heated is pumped through the cold fluid inlet H into the distributing chamber D2. Cold fluid inlet is where? H point, which is getting introduced into the distributing chamber, that is D2. Now the fluid will flow through the tubes and the steam and the fluid are physically separated but are in thermal contact through the thin tube walls. That's why the tubes which are present inside the casing are thin walled. Okay, so they are, both the fluid and the steam are in the thermal contact with each other through the thin tube walls. Okay, now the fluid in the tubes get heated due to the heat transfer by conduction, that is through the metal wall. Conduction process, mechanism of heat transfer, we have studied conduction, convection, radiation. First one is conduction. So the fluid in the tubes are getting heated by the conduction mechanism of heat transfer. Okay, which has been followed by a stagnant layer and finally by convection. Convection is the heating of the liquid molecules. Okay, now the total heat transfer is affected by the single pass of fluid. Okay, thus the heat fluid reaches the distributing chamber, that is D1, and leaves through the hot fluid on outlet, that is your I. So this was the working of our tubular heater. In this sheet and tube heater, the cross-sectional area of the tube is larger. Hence, the velocity of the fluid inside the tubes is low. If the area is smaller, then velocity will increase. Okay, so what are the advantages of this single pass tubular heater? First, basic advantages: large heating surface is provided in this, which can be packed into a small molecule. Then what are the various disadvantages? First one is velocity of fluid is low because of the large cross sectional area. You can see that its advantage is again its disadvantage also. Okay, and second one is the expansion of the tubes and shell takes place due to the differences in the temperature, which may lead to the loosening of the tube sheets or buckling of the tubes. Okay, so this was your construction working principle, each and everything of your tubular heater or shell and tube heater or single pass tubular heater. Next one is your multipass heater. In multipass heater, the velocity of fluid can be increased. As a result, the heat transfer coefficient also increases because the velocity is increasing, and by the name itself indicates that the liquid to be heated is passed through the tubes several times before leaving the equipment. In single pass, the liquid will enter the casing and it will flow only once and it will exit the chamber. Okay, but in multi-pass heater, the liquid is flowing several times inside the equipment. This facilitates the effective heat transfer. Therefore, multi-pass tubular heaters are superior to single pass shell and tube heaters. Okay, now let us see the construction part of multi-pass heater. It is as same as that of tubular heater with some modifications. Okay, this tubular multipass heater consists of a bundle of parallel tubes, and the ends of these tubes are expanded into two tube sheets. Okay, the tubes bundle is wrapped inside a cylindrical casing. Again, two distribution chambers are provided at each end of the casing, the same as that of single pass tubular heater. Since the heater is multi-pass, the same liquid has to flow through that several tubes back and forth. Okay, in order to facilitate this process, distribution chambers are partitioned by the means of baffles, and their arrangements are different in two chambers. So the entrance and the exit points of the fluids are arranged in the same distribution chamber. Okay, so this was the construction part of our multipass heater. Now how it works? Same, steam is introduced through the connection into the space that is surrounded by the tubes. As steam flow down, the tube get heated and the condensed vapor is drained. Again, the non-condensable gases will be escaping from the vent provided at the top of the casing. Okay, the fluid that is to be heated is pumped at high velocity into the right distribution chamber through the compartment A. High velocity facilitate what? Effective heat transfer. In this construction, the fluid is directed to enter only a fraction of tubes by means of baffles, which is placed inside the distribution chamber. Okay, when the liquid is entering compartment A and flowing through the left into the compartment that is B, back to the right to the compartment, and so on as in the sequence of your alphabetical order. Okay, because the liquid has to be flowing back and forth to get the effective heating. And during this process, fluid in the tubes get heated due to the heat transfer by the conduction through the metal wall, which is being followed by the stagnant layer and finally by the convection. So again, this was your working of multipass heater. Again, what are the various advantages? These are the advantage of multipass heater. First one is these are superior to the single pass and tube heater. The best advantage. Disadvantages: fabrication of multipass heater is more complicated. It is a stinky design. Okay. Second one is the pressure drop through apparatus is increased because of enhanced velocity of fluid flow. And third one is more number of exit and entrance points increase the friction losses. Okay. Thank you, students. So this was all for today's section. Rest of the part we'll cover in our next section.